standard enthalpy changes. Standard enthalpy changes. Okay, so first let's have a look at this equation here. So if we take some a chemical, for example ethanol, for example. Now ethanol has a formula. That's the formula of ethanol, and at room temperature ethanol is a liquid. This is ethanol. Now if we combust ethanol and we combust it in oxygen, standard state is gas, what are we going to make? Ethanol plus oxygen is going to make carbon dioxide gas. The state symbols are really, really important. And water liquid. Okay, it's the states at room temperature. Okay, now when you're balancing this kind of equation, then you always balance the carbons first. So there's 2 carbons, so we put 2 here. Okay, balance the hydrogens next. There's a total of 6 hydrogens. So we need 6 on this side, so we put 3, which will give us 6, and then balance the oxygens last. 4 oxygens, 3 oxygens, that's 7 oxygens in total. So 7 oxygens on the right hand side, 4 and 3. So on the left we need 7 oxygens. Already got 1 oxygen here, so we only need 6, so we just put a 3 there. Okay, so now we've got 6, 7 oxygens, 4 oxygens, 7 oxygens. Okay, so that's how you balance this kind of an equation. You always start balancing the carbons first, then the hydrogens, and finally the oxygens. Now this kind of equation is called a combustion reaction. It's called a combustion reaction. And we need to measure the enthalpy change, the change in enthalpy during this reaction. Okay, so we're going to measure the enthalpy change of this reaction, and because it's called a combustion reaction, we put a little C down the bottom, which means combustion. Okay, so let's just label the symbols. So that bit there means enthalpy change. Enthalpy change. That little C means combustion. And then we have another symbol which is called a theta. It looks like that, a little bit like the London Underground symbol. It's called theta, and that means standard conditions. Standard conditions. Okay, so we're going to measure the enthalpy change of this reaction under standard conditions. Now what does standard conditions means? So standard conditions means that you're doing your experiment under standard conditions, which means that the pressure in the room is 1 atmosphere. The pressure in the room is 1 atmosphere, or it can be written in kilopascals, which is 100 thousand pascals. Okay, so that's the pressure in the room. That's standard conditions. The temperature is 25 degrees in the room when you're doing this experiment, and we can also write that as 298 Kelvin, capital K, Kelvin. Remember the relationship? The relationship is, let's write it up here, the relationship is Kelvin equals degrees plus 273. So if 25 degrees, that means that's going to give you 298 Kelvin. Okay, these are standard conditions. If you have a solution, the concentration of the solution has to be 1 mole per decimeter cubed. That's the concentration of any solutions. This is called standard conditions. Concentration of solutions, and then finally all chemicals must be in their standard states at this temperature and pressure. All chemicals must be in their standard states. And that is why state symbols are so important, must be in their standard states. Okay, so if I said to you to write an equation, to write a question here, if I said write an equation to represent the standard enthalpy change of combustion of ethanol, what would you write? So if I said to you, write an equation to represent the standard enthalpy change of combustion of ethanol, that is the equation that you would write. It's combustion of ethanol. It's done under standard states, and it'll be done at room 1 atmosphere, 25 degrees, and any solutions will be that concentration. Okay, now you need to know the definition for this. Okay, the definition, so that's just something you have to learn. Okay, so the standard enthalpy change of combustion this is just a definition. Okay, it's just a definition, and the symbol standard enthalpy change standard of combustion is the enthalpy change when 1 mole of a compound is completely combusted in oxygen under standard conditions. This is the definition. Under standard conditions. Okay, so enthalpy change of combustion, standard enthalpy change of combustion is the enthalpy change when 1 mole of a compound is completely combusted under standard conditions. So when you go back to the equation, you see that 1 mole of the chemical is completely combusted under standard conditions. So you never put a number apart from the number 1 there. No number goes there. You cannot put 2 because that is not combusting 1 mole of a chemical. That has to be no number there. It's either 1 or no number. Combustion of 1 mole of a chemical under standard conditions. Okay, now through experiment, how do you determine this? Through experiment, how do you determine this value? Okay, so what you need to do is you need to combust your sample. Okay, so you tend to have this is how to do it by experiment. By experiment, this is what you do. How do you find this value? So you have a calorimeter, which is just basically a copper can, a calorimeter, and you measure some water. Maybe I put about 100 centimeters cubed of water in there. Measure some water, and you put a thermometer in, and you get the initial temperature of the water. Okay, then you've got something called a spirit burner, which is a little container which has got a fuel in it. And it's got a wick into the fuel like that. Okay, it's called a spirit burner, and it contains a fuel. Okay, and you weigh the spirit burner before, and then you weigh it after, and then you light the spirit burner so the fuel is combusting, and you're measuring how much energy is transferred to the water. Energy transferred to the water, absorbed by the water. Energy transferred to the water, or the energy absorbed by the water. So you're going to try this experiment in lesson, but the calculation that you do in order to calculate, so this is the calculation for the enthalpy change of combustion, standard enthalpy change of combustion. Okay, so what you do, the first thing you do is you calculate the energy absorbed by the water or transferred to the water. Energy absorbed by the water. And now this is given the symbol Q in chemistry. Energy transferred to the water. And we use Q equals mc delta T. Okay, so the first thing you do in the calculation. Now m is the mass of water. The mass of water. And we say that 1 centimeters cubed of water is the same as 1 gram. It's the same as 1 gram, okay? So in our case, the example we've given there, it's going to be 100 grams of water, because we put 100 centimeters cubed in the calorimeter. Because we are measuring the energy absorbed by the water from the fuel, okay? Now, C is the specific heat capacity of the water. Now it's always given to you in questions, it's always given to you, okay, and it's normally, the value normally for C is 4.18 joules per gram per Kelvin, and it's always given to you in exam question. You don't have to remember it, okay? And that tells you that what it actually means is, so what that actually means is 4.18 joules of energy is needed to heat 1 gram of water by 1 Kelvin. Okay, now remember when we talked about kelvins last time? A Kelvin, the Kelvin is exactly the same as a degree in terms of temperature change. Okay, it's exactly the same thing. Okay, well, 1 Kelvin. And then your temperature change is your final temperature, take away your initial temperature, and it should be in kelvins. But a change is going to be exactly the same as in degrees, okay? So when we do this calculation, we see that we've got the energy absorbed by the water is the mass of the water times 4.18 joules per gram per Kelvin. And let's put pretend number in. Maybe the temperature change was 20 degrees, which is the same as 20 Kelvin. So let's just put in pretend, let's put pretend 20 Kelvin, 20 degrees. That's how much the temperature changed. Okay, now you can see with the units, when you're looking at the units here, you've got Kelvin divided by Kelvin. Remember that when you've got to the -1, that actually means 1 over. When it's to the -1, it means 1 over. So we've got Kelvin divided by Kelvin, so that can cancel out. We've got gram divided by gram, so that can cancel out. So our units, when we do this calculation, and whatever the answer is, it is going to come out in joules. I mean, I don't know what the answer is here, but it will come out in joules. That will be the units. Okay? Okay, so that's the first part of the calculation. Okay, energy absorbed by the water. It will be a positive value because the energy is being absorbed by the water. Okay, now the second stage. Okay, energy absorbed. So the second stage is we need to work out the moles of fuel that have been burned. The moles of fuel that has been burned. So this is in the spirit burner, okay, because you weigh the spirit burner, this part here, you weigh it at the start, then you burn the fuel, and then you weigh it at the end, you get the difference, and that's the mass of fuel burned. So if it was ethanol, for example, to get the moles of fuel burned, moles equals mass of the fuel, mass of ethanol, if that was a fuel, over the molar mass of ethanol. And that is how you work out the moles. Okay, whatever that is. Okay, that's the second step. And the final step, okay, step 3 of the calculation. We're trying to find the enthalpy change of combustion of every mole. Okay, kilojoules per mole. Right, so what answers have we got so far? From part one, we have got a joules. Yeah, so the next thing you've got to do is you've got to divide it by 1,000 in order to get kilojoules. You have to divide it by 1,000 in order to get kilojoules. Okay, and then from part 2 we've got the moles. So what you've got to do is you've got to go kilojoules divided by the moles, which is what we got from part 2. And then you've got your answer in kilojoules per mole. Okay, and then finally, this is combustion. This is an exothermic process. Energy has been absorbed by the water. Energy has been lost by the chemicals, exited from the chemicals. So you've got to remember to put a minus in, because your answer is going to be exothermic. Okay, exothermic. Enthalpy change will be exothermic. Okay, so that's how you work out the standard enthalpy change of combustion of ethanol or any fuel. Right. Just quickly mention a couple of other standard enthalpy changes. So that is a well-known one. You also need to know the definition for the standard enthalpy change of formation. Standard enthalpy change of formation of You also need to know that definition as well. Okay, standard enthalpy change of formation. And the F stands for formation. Okay, so if, for example, we had, let's just take any chemical, let's take ammonia. Okay, so it's for the formation, for making ammonia. Ammonia is a gas. You've got to have the state symbols. Forming 1 mole of a compound from its elements in their standard states. So from nitrogen and hydrogen in their standard states. Okay, so you're forming 1 mole of a compound from its elements in their standard states. We just need to balance the equation. So we've got 2 nitrogens. You need to put 2. Oh no, you cannot do that. You cannot put a 2 there, because the definition is formation of 1 mole of a compound. So you can't put a 2 there. So instead you've got to put a half there. And then we need 3 hydrogens. So we're going to need here 3 hydrogens. So we're going to need 1.5 there, because 1.5 times 2 will give us 3. Okay, and the data definition, that's the standard enthalpy change of formation. So it's just giving a special name to an equation. The definition is the standard enthalpy change of formation is the enthalpy change for the formation of 1 mole of a compound from its elements in their standard states. Formation is the enthalpy change for the formation of 1 mole of a compound from its elements in their standard states. Okay, and the last standard enthalpy change you need to know is the standard enthalpy change of reaction. Okay, the standard enthalpy change of reaction. So there's 3 you need to know. There's combustion, formation, and the last one is reaction. Okay, now this is just for any reaction, So formation is specifically for forming a compound. Combustion is specifically for combusting a compound. This is for any reaction. So let's just take any reaction. Let's just take this reaction, okay, just any reaction. So let's just take the decomposition of this compound here. The decomposition of this compound will break down into this compound here, okay, and the standard enthalpy change for this reaction is 58 kilojoules per mole. Positive 58 kilojoules per mole. It's not combustion, it's not formation, it's just a reaction. Standard enthalpy change of reaction. You still need to know the definition for this. So the definition is the enthalpy change for this one. Standard enthalpy change of reaction is the enthalpy change. That accompanies a reaction. In the molar quantities expressed in a chemical equation, under standard conditions. And that's everything under standard conditions. Okay, so basically that just means that in the ratio, it's in the ratio 1 to 2, in that ratio, that is the standard enthalpy change of reaction. Okay, for the ratio of 1 to 2.